This is the Anthrobiology Podcast, hosted by me, Gabby LaPera. Every 2 weeks, I interview a biological anthropologist about what makes us, us. Hello, everyone. Welcome to the Anthrobiology Podcast. I am very excited to have Dr. Bill Schutt join me here today. Anyone who has listened to this show has heard me grumble about popular science writers before, which is why I'm so excited to have Dr. Schutt here, because you are, I think, honestly, the best popular science writer that exists. And that is probably because you were originally, and still are, a scientist.
Thanks. Wow. I don't know how to follow that up.
You're also just an incredibly charming human being. And I'm really excited to have you here because you've written a new book, and it's called Pump, A Natural History of the Heart. And I read it all in its entirety. It's excellent. Let's just go ahead and start with that. I think if anyone is looking for a book to read, you should read this book.
Thank you.
You're welcome. That's what they sent you here to say, right? Like, read my book.
Yeah. Well, hopefully there'll be a little bit more than that. Look at the pictures as well.
Yeah, for sure. Actually, well, we've gotten the read your book out of the way, so now we can actually talk about the book and like have an exciting conversation. One of the things that I really appreciate about all your books is that you have a illustration partner. Her name is Patricia Wynn, and all of her illustrations are incredible, and they really bring your book to life.
Yeah, thanks. So we've been working together for, I guess, like 30 years, and she has illustrated every scientific paper I ever wrote, and that's about 24, some book chapters from back in the Cretaceous period that I wrote, and now all three of my novels, and then, well, now all three of the nonfiction. So I'm just very lucky. She's an incredibly talented illustrator and artist, and has contributed to over 250 books. So that pretty much says it all. And her and her husband make a very nice living just by doing this sort of thing. They're both artists in New York City, and I'm just thrilled that I've been able to hang out with her. We've been office mates at the American Museum of Natural History for a long time.
That's so wonderful. I love seeing those kind of like super healthy long-term relationships in academia. You don't always get to see them, so it's nice when you do. So your book, it is about the heart. One of the things that I really like about the way that you structure books is that even from the beginning, like it's to me, it's very clear that you are an architect when you write books, and you have like a whole storyline that goes throughout it. And you always start with like the basic science and then build up from there. That's definitely one of my favorite parts about the book. And so you start with a lot of information just about how hearts have evolved. And one of the things that I like that you've done, and that I think happens a lot in research, is that you take extremes to illustrate points about how things work. Can you talk a little bit about one kind of extreme that helps illustrate how the human heart works?
Well, how the human heart works. Well,
Or
the human
any heart, if you want.
Sure. Well, the human heart is a mammalian heart, so of course there are similarities to the wonderful blue whale heart that my friends at the Royal Ontario Museum in Toronto were able to recover. You know, it started off, it was a tragic story. 9 blue whales died on the ice off the coast of Newfoundland, and usually these whales sink when they're killed. So this is why during the whaling industry, they were not called the right whales. These were sort of the wrong whales, because the right whales, when you threw a harpoon in them and they died, they floated, and these sank. So biologists up until really recently didn't really know a whole lot about their anatomy, say. So my friends at the ROM, a couple of them were whale experts. We're getting questions for years and years, like, what's the largest heart in the world? Blue whale heart. How big is it? It's the size of an SUV. But they really didn't know. So when they got the opportunity, because 9 of these whales died, and 3 of them didn't sink. 2 of them washed up in these small little fishing towns. Surprise, that sort of thing. And they were just gigantic 90-ton bloated thing that was, they were all paranoid that it was going to explode in the town. So my friend Mark Engstrom and his crew went to these towns, and they said, "Don't, unless you're jumping up and down on them or stabbing them, they're not going to blow up. They're going to sort of deflate, you know, like an old balloon." But they were able to get inside this thing, and the organs were not decomposing, and they were able to recover this heart. So that sounds kind of easy, but we're talking about like 4 people inside this animal, big stinking dead thing, pushing this 400-pound heart out between the space that they used jacks to pull the ribs apart up to get this thing out. And when I saw the pictures of it, and they probably thought along similar lines, it didn't really look like a mammalian heart. To me, it looked like a 400-pound soup dumpling. And so, if you went to the butcher and you got a beef heart, it would look, it would kind of look like our heart. It has structure to it. It's a firm organ. This thing collapsed like like a 400-pound soup dumpling. And so that was kind of odd. And the more that they looked at it, and as they, then they transported it, of course, and then froze it for a year, and then rinsed it and put it in vats of formaldehyde. We're always worried when we were working in labs that we get some of this stuff splashed on ourselves, and then everyone would freak out. But they were using vats of 1,000 gallons of formalin, and they were worried about falling into these vats. So, yeah, so the size of the thing, it was actually smaller than they thought, though. That was the key. I mean, this was something that they didn't expect. So even though it weighed in at just about 400 pounds, so it took them 5 years to preserve it, because they sent it over to Germany. And you've ever seen to be plastinated? When you've ever seen the bodies exhibit where you've got, there's a guy dribbling a basketball, but he's got no skin, and his body's made out of plastic.
Uh-huh.
Yeah, that's what they did over there. This was the largest organ structure that they'd ever plastinated. And when it came back 5 years later, it was just stunning. The vessels were all color coded, so you could see the difference between the arteries and veins. But the main thing, well, one of the main things was it was a whole lot smaller than they thought it would be. So, for example, if you'd had a 90-ton hummingbird laying next to this blue whale, and you'd have gone in and looked at its heart, that heart would have been 8 times larger than the blue whale heart. And we think that this has to do with the fact that hummingbirds beat their wings 80 times per second. And in order to do that, you've got to supply their wing muscles with oxygen and nutrients. Well, one way that you can accommodate that is that they've got a crazy heart rate. Our heart rate is what, 80, 70, 80, 60 beats per minute, something like that. Well, theirs is beating at 1,260 beats per minute.
That's insane.
Which is, we think it's about the limit that this structure, if you consider it to be a machine that has to sort of fill and then empty, to do that 1,260 times is probably right at the limit that the structure could function. So if you're going to get more blood to the wing muscles, the only other way to do it is to have a larger heart. And so their heart is extremely large compared to a blue whale heart, his heart may beat 15 to 12, 15 times a minute. And then when it dives, maybe 2 or 3 times a minute, which is why the thing they believe collapsed looks like a soup dumpling. Because when they go to these deep dives, instead of having to resist this tremendous pressure that they're now under, the heart just collapses. So we think that's an adaptation to deep diving. But there were blood vessels on this thing that they still couldn't identify. So there was, given that this was a mammal heart, they're still learning about it, and now have got a closely related whale heart that they're preserving so that they can make comparisons. One of the great ways to look at and to study organs, and I sort of made a living of this when I was looking at vampire bats, is to look at 2 closely related species and see what the differences are and the similarities, and then match it up to how they make their living.
For sure, for sure. So a bunch of different things to unpack. First, I guess I never mentioned that you used to study bats. That was your bread and butter. That's part of the reason you were a scientist before you started writing popular science, and that's why your popular science is so good, because you actually understand the science, which is just more rare than you would expect. And then I really love that you use 2 animals at the extremes, right? Hummingbirds and blue whales, to illustrate the fact that hearts can be so different. Side note, I live in California and there are hummingbirds everywhere here. No one really told me about that. Hummingbirds are kind of jerks. Like, you're just walking along, minding your own business, and they're like, hey, hey, hey. And you're like, I'm sorry.
Can I quote you on that? Hummingbirds are jerks.
Feel free. I have a very small dog, and she and the hummingbirds will get into fights that the hummingbirds always win. Anyway.
Yeah, I think by using extremes, you can. I don't write textbooks. That these are books for I'm writing to an audience who's interested in science, but doesn't necessarily want to be lectured. And I do try to get some important points across. And when you use extremes, or when you use weird examples, memorable examples, funny examples, then I think you increase your chances of having people bring that topic up at at the dinner table, for example. Although with cannibalism, that was a bit iffy. I had friends tell me they would sit on the subways reading my book, and they would just look around, and everybody had moved away.
Um, so I'm currently doing research for an entire show on cannibalism, and the first time the guy that I'm seeing came over, there was like a stack of 20 books on cannibalism just sitting on my dresser, and he was like, "Cool."
My type of podcast.
um, no, I think one of the other things that I really appreciate your book is that your book actually kind of mirrors the way that I think a lot of people think about things, and it actually mirrors a lot of natural processes, right? Like one of the things that you say in your book is that evolution isn't a straight line, right? And I think your books also aren't a straight line, but there is like you can see kind of like the thread that goes throughout it. And you can see where you started and how you ended in it. And I think that that's such a beautiful thing. I really like that you talk so much about evolution in your book. I think it's really interesting. And it's really interesting to think about how this one organ exists in so many different kinds of creatures and in so many different kinds of ways. You spend a fair amount of time talking about horseshoe crabs. I grew up on the East Coast. Uh, and I still remember the first time I brought one of my friends from California out to a beach there, and they saw a horseshoe crab and they're like, "What is that monster?"
It's like a living helmet.
Hmm.
I've been seeing I grew up and stayed around here, and I'd always see these pickup trucks during the late spring, early summer, full of horseshoe crabs. And I wondered what was going on with them. This is a creature that has been around for half a billion years. This is really, I think we throw around the term living fossil a bit too much, but this is really a living fossil. Half a billion years ago, horseshoe crabs look like horseshoe crabs. That's 250 million years before the first dinosaur. So they've been around a while. And it's only over the last 150 years or so that they're endangered. And it's mostly because of humans. First of all, we were using them for fertilizer. Thankfully, that passed. That was early 20th century, late 19th century. But then eel fishermen and whelk fishermen figured out that they could use these things for bait. But in the 1960s, the hammer really fell on horseshoe crabs when researchers figured out that there was a substance in their blood, which is blue. And I go into that. Why is it blue blood? The substance in their blood that, when it came into contact with endotoxin, would give a visible response. It would form a clot. And so they made a test out of this substance that they derived from horseshoe crab blood. So these horseshoe crabs that I saw in the back of pickups were being driven to industrial size companies where they'd hang these things up in rows and rows and drain blood out of them until it stopped dripping. No refrigeration, they're not in the water. And then by law, they had to return them to the water but within 72 hours. Now you've drained 40% of their blood. You kept them out of the water at a high temperature, generally speaking. A lot of them died.
Yeah.
And so now that's not to say that this compound that they isolated wasn't incredibly useful and saved many, many lives. Because to make a long story short, endotoxin, at least some endotoxins, are produced when you kill certain bacteria by sterilizing, say, a room where you're going to do surgery or catheters or other equipment that you need to be sterile. And if there are these bacteria near there, when you sterilize them using whatever means, you burst their cell membrane, and this material that used to be in their cell membrane is now floating around. And if it gets into your circulatory system, that's an endotoxin. It can kill you. And so this substance in the horseshoe crab blood can detect that stuff. So yes, it saves lives. Fortunately, not too long ago, using DNA technology, a test was developed that would react to endotoxins without using horseshoe crab blood. And at the same time, Cornell researchers were coming out with a synthetic horseshoe crab scent that they were giving to fishermen, the eel fishermen and whelk fishermen, so in theory, you could put this stuff on a roll of toilet paper and put that into your trap, and eels and whelk would be attracted to it, thinking that it was horseshoe crab. So I was interviewed by my friends at This Week in Science a couple of weeks ago, and one of the interviewers, Blair, chimed in immediately and said that they should name it "Can't Believe It's Not Horseshoe Crab." So I thought that was a great name. I may try to pass that along to the folks who are building this stuff.
No, I love that. I think one of the interesting things about your book too is that it's super timely. One of the things that you mention is that COVID has actually kind of set back this research on substituting synthetic substances for horseshoe crabs because people have just been so desperate to get stuff done that they just fell back on old ways.
Yeah, and there were a number of companies that they could fall back on that could supply this material that they desperately needed, and it's just too bad. And hopefully, once COVID is under control, if it ever is, we will be able to go back and utilize this new test, and by the same token, save these animals from being used as bait.
For sure. For sure. I love horseshoe crabs. I love how you describe them as like just angry helmets. They're just great animals. One of the things I wanted to ask you is why did you write this book? I feel this is a little bit like when people ask me why I got a tattoo, but I want to know like what happened. You went from bats to cannibalism to hearts.
Yeah, well, I was going to get a tattoo, and then my agent and my editor said, "No, you should write a book about the heart." No, no. In reality, I'd written about vampirism in nature, and then cannibalism, and I had this list of really rude stuff that I wanted to work on next. And they sort of took me aside and said, "Bill, why don't you try for something a little bit more mainstream?" And one of the things on the list was the heart. And initially, I thought, no way. There has to have been so many books written on the heart that there's nothing that I can do to go in and write the kind of book that I wound up writing. And I just I thought somebody's done that already. And I luckily found out that not only hadn't that book been written, but there was all sorts of weirdness in there that I could go in and mine. And to me, it was quite a bit of it was just as weird as cannibalism and blood feeding. So I mean, I was always attracted to the macabre. And when you go back and look at the history of cardiac medicine and what we thought about the heart for so long, that was just I couldn't pass that one up. So I had to go in and I jumped all over those stories.
Yeah, those are some of my favorite chapters are the ones where you deal with kind of the history of especially Western understanding of how the heart works. What was that like for you? Do you enjoy history? How
Oh,
did
no
that
doubt.
go?
Oh, absolutely. But to me, that is nearly as important to me when I'm writing books as the actual science, and especially when there was just so much interesting stuff going on. You know, when I wrote a book about cannibalism, I was intrigued by this question of why do we have this knee jerk reaction? Whenever you say that word, people react the way they do. And so an early version of the book chapter that went into that was called Blame It on the Greeks. And so when I started to work on a book about the heart, I wondered how we got this idea that the heart was the center of things like emotion and the soul and intellect and memory. And that chapter could have been called "Blame It on the Ancient Egyptians." So so that to me was really intriguing. And then I'd always been interested. Galen pops up in now all three of my nonfiction books, and I've always been intrigued by and sort of mortified by the fact that while there was growth in just about anything you could name as far as architecture, fill in the blank, it just didn't happen in the field of medicine, which stagnated for 1,500 years. And it all goes back to this second century CE Roman surgeon, Galen. And to me, that is that's a story worth telling just because I think it's applicable today because we need to avoid the type of lockstep following of dogma that was so common and caused so much grief for 1,500 years.
For sure. And just for listeners, one of the things that happened is that the Catholic Church decided that Galen was right and that it was heretical to think differently about medical topics. And it's very interesting to see how religion and science have been doing kind of this dance for so long. I actually interviewed an author, an anthropologist named John Marks, not too long ago. He wrote a book called "Why Are There Still Creationists?" A very provocative title. But one of the things that he examines is this like relationship between science and the church. And if this is something that you're interested in, I think that your book is something that people should definitely read as well.
Yeah, thanks. I just there were aspects of that story that I thought I knew, but I really didn't. I didn't know that that initially Galen's works had not been translated into Latin, which was that was the language of scholarship in the West, and then they sort of sat and Galen wasn't a Christian. I don't think he was a Christian, but he may have been a monotheist. And the people who eventually translated his work were Syrian Christians, and they put their sort of Christian slant on that translation, realizing that Galen was a monotheist. And then when they translated it into Arabic, and when their work was finally translated into Latin, that's when the church in the West looked at it and said, "Hey, this is cool stuff. Nobody needs to do research. We just need to follow the word of Galen."
Yeah. No, I think the other thing that's interesting is that you also pull in when you can throughout the book things like traditional Chinese medicine, Ayurvedic medicine, and then also looking at non-Western research into the heart. And there's other people who'd figured out a lot of stuff before the West had.
Oh yeah, I mean there were two or three people that came up with there was this idea of if you're watching Jeopardy and the question is who came up with the idea of two circulatory systems, really the systemic circulation pumping blood around the body and the pulmonary circulation taking that blood that's coming back from the body and sending it to the lungs. The answer is probably going to be William Harvey, but in reality, up to 350 or so years before that, there were researchers in places like Syria and in China who had come up with this idea that the heart is really a double pump,
Hmm.
that the deoxygenated blood doesn't mix with the oxygenated blood. And, Galen was not one of those guys, unfortunately. And
Yeah.
so it wasn't until the 1600s when Harvey came out with this that the West finally realized that a lot of what Galen had said was completely wrong. They believed that arteries contained air. Other than that, they nailed it. But that was something that up until the 17th century, that was a given.
Yeah.
If you want to maintain mental and physical health, you had to balance the four humors. All of that was, related. Galen cribbed that from the Greeks, and the Greeks probably cribbed that from the ancient Egyptians.
Yeah. And one of the things that you point out in your book is that we still like think about those humors today. Like we still have the words for people who are, for example, sanguine. I've actually never said that word out loud. Phlegmatic. Uh, but like it's there. I've read it. I read a lot of fantasy novels, and I can't tell you how many heroes are described that way.
Yeah. Well, that's what remains is that the part of that language, and I think that's because once the Egyptians, that material was held in such high esteem by the Greeks and then by the Romans, the artists jumped right in there and they took it for granted that the heart was the center of emotions, and even Aristotle thought that the brain was a radiator to keep the heart cool. So so there was a lot of misinformation out there.
Definitely, definitely. My question for you: what is your favorite heart?
Oh, oh, let's see. What is my favorite part? I have to think about that for a sec. What just popped into my head? Oh, I really can't pick one out. I can't. What the closest I can come to that is that when you look at the hearts in vertebrates, so fish, amphibians, reptiles, birds, and mammals, there is a similarity. No matter which animal you're looking at, there's a similarity there because we believe that all of them evolved from one common ancestor. That's just not the case when you look at the invertebrates, the animals without backbones. And there, the variation that you see and the different ways that these structures have evolved to really do the same thing, is to circulate oxygen and carbon dioxide, and move around nutrients and waste products. But the variation that you see there is, to me, astounding, and really has to do with the fact that I believe that, and a lot of folks believe, that these structures, that these systems evolved many times in the invertebrates, many times.
Yeah, I that's really cool. I have to say that my favorite heart from your book was the Burmese constrictor
Ah,
python.
yeah. Okay.
I thought that was so interesting. I don't want to give I don't want to give spoiler alerts on how this very ancient biology works.
Yeah. To me, the examples like that were things that were a complete surprise to me. This was not an encyclopedia, so I wanted to pick neat stories, cool animals that had, unique structures, or something really cool about their hearts and circulatory systems. But what I found out was that most of them, including the Burmese python, which is a serious problem in the Everglades right now, it's an invasive species. Most of them are tied into modern cardiac research, and they may be providing clues for researchers on how to improve life in the future for people that are suffering from, problems with their hearts. That blew me away. That connection between a number of different animals, from zebrafish to pythons and Antarctic ice fish. That was a real surprise to me.
Yeah. Yeah, no, it's your book's just so interesting. Congratulations on such an
Thank-
interesting book. Which means I should ask you actually, what didn't make it into the book that you wish would have made it?
okay. Well, so human hearts, and let's just take mammalian hearts. They beat because of an electrical signal that stimulates the muscles, and when they're stimulated, they contract. But that signal comes from within the heart, from specialized tissue called a pacemaker. So that's the type of heart that we have. And there's a very, very different type of heart that's very common in the animal kingdom, for example, in horseshoe crabs. And so I thought about that I would have this kind of snarky chapter that started out by explaining why you never see Aztec priests pulling out the hearts of warriors on the top of pyramids, and holding up a horseshoe crab heart to the crowd below and having it beat, because this is the type of heart, a neurogenic heart, where as soon as you removed it, you're pulling the nerves away that are on the outside of the heart that cause the heart to beat. So I wrote this entire scene about this warrior who gets captured, and he's marched up this pyramid, and meanwhile I'm explaining things like how the autonomic nervous system, his fight or flight response, is now dumping all these stress hormones into his circulatory system, which causes his heart rate to go up, and his breathing rate goes up, his blood pressure, his eyes dilate, his pupils dilate, and it ended with this big gory scene. so so I probably got a little bit carried away. I hadn't written fiction in a while, so I just kept going, and my editors were like, "Oh yeah, okay, well, it's I think it sort of stopped the engine, and they wanted to keep the any type of momentum that I happened to be generating going, rather than people running away because I was grossing them out with a torrent of blood pouring down the walls of this pyramid while this guy's heart rate went up.
Listen, I would have loved it. Temple of Doom was my favorite Indiana Jones movie. Highly underrated.
Yeah, well, I'm hoping that maybe I'll use the chapter someplace, maybe in a magazine article or something like that. But yeah, that was that was the one that got the U out.
I will definitely keep that in mind. It is definitely interesting. I work as an editor now. So a lot of my work friends, they're English people, and so sometimes I'll be sitting around and I'll bring something up without thinking about it, something that would be totally cool with my science friends, and they're like, this is disgusting. We're trying to eat. What's wrong with you?
Yeah. I don't know. I thought I could pull it after a book on cannibalism that people didn't grab about because that no one said it was sensationalistic. I kind of figured out. All right, well, let me see if I can sneak this Aztec, the human sacrifice chapter in there. I don't know. It's probably about 30 pages long or something like that. I don't know. Who knows? Hopefully, it'll pop up again.
Well, like I said, I hope to see it. I want to be respectful of your time, so I'm going to wrap up the interview with the final three questions that I ask every one of my guests. The first question is, and I think the answer to this one is probably very easy. If someone would like to learn more about your work, what should they read?
Oh, what should they read? I mean, if they want to find me online, they can go to billschutt.com, or I'm also on Twitter at Bill Schutt Books, Facebook, Bill Schutt Author. But happily, all six of my books, the three novels, it's a trilogy, sort of a World War II cryptozoology with sort of, I guess McCready's been described as the Indiana Jones of zoology. Those three books are available in any format still, anywhere that you want to buy your books, and the same for Dark Banquet, the book about blood and blood feeding and cannibalism, a perfectly natural history, and then happily Pump, a natural history of the heart is available also wherever people want to pick their books up.
Yep.
So
Strong recommend on all the books. I obviously can't say enough good things about you. I want you to leave this interview and just be like completely read. You're gonna go to another room and your partner's gonna be like, "What happened?"
yeah, I'm gonna have to like oil the outside of my head to get through the door.
Good. Second question: what are you reading for work right now?
Oh, what am I reading for work? Oh, for work. Well, hmm, I'm not. Am I really reading anything for work right now? Probably not. The nonfiction that I'm reading is a book called "Your Pretty Face Is Going to Hell." It's a story about the rise of Iggy Pop and David Bowie and Lou Reed. And then for fiction, I'm reading a new collection rather of H.P. Lovecraft short stories. But yeah, I'm not reading anything right now for as far as
That totally makes sense. You're in the middle of a media blitz, so
yeah.
congratulations on being able to read for fun.
Yeah, thanks. I mean, I've got to keep sane, and nothing keeps you more sane, I say, than H.P. Lovecraft or something like that. But
I recently started watching this pretty terrible, honestly, Canadian murder mystery series called Murdoch Mysteries. And it's set in the like turn of the 20th century. And one of the conceits is they constantly have these characters on like Mark Twain and I don't know, Tesla, but H.P. Lovecraft as a teenager makes an appearance in it.
huh,
They're really not very good, but I can't stop watching them.
yeah, see, that to me when I was writing fiction, that was to me the most fun thing was to bring in, and I would bring in all of these great people from the 1940s and well, mostly 40s because it took place around World War II. And so we're talking about Alfred Hitchcock coming into the Museum of Natural History and his adventure there. So I love bringing in historical figures and sort of playing around with them, and that's something that I never thought I'd be able to do. So I enjoyed that. H.P. Lovecraft. Now I haven't done him yet, but a bunch of other folks.
He definitely in his personal life was quite a strange man.
Yeah.
Shocking no one perhaps after reading his fiction.
Yeah.
Anyway, thank you so much for coming on the show. You were lovely as usual. You are welcome to come
It's
back
a
anytime
pleasure.
you want.
Oh, thanks. I love coming on your show and talking to you. We seem to have quite a bit in common as far as our tastes go. So I just wish you a lot of luck with your continued luck rather with your podcast and everything else you're editing. And
Thank you. That is so kind of you. If you're ever in the Bay Area, I will buy you coffee.
oh, cool. I love San Francisco.
Well, come on out. Post COVID.
Thanks. Yes, of course.
All right.
All right. Take care.
Have a wonderful day.
Bye bye, Gabby.
Bye. Thanks for joining me for this episode of the Anthrobiology Podcast. If you have questions or comments, you can reach me at gabby.lapera@anthrobiology.com. That's spelled GABY.LAPERA@anthrobiology.com. This show is produced by me. Music courtesy of Chad Crouch, aka Poddington Bear at Sound of Picture.